Okay, so now we go into products and quotients. So how do you differentiate the product of two functions, or how do you differentiate the quotient of two functions? Is the derivative of a product equal to the product of the derivatives? Actually, that's a good question, right? Let's take a look and see if we can understand this, right? So a little experiment, okay? We know the answer to this question. What is the derivative of x squared? Instantly, you can say that's 2x, right? What's the derivative of x cubed? Instantly, you can say that's 3x squared. It's so nice not to have to take the limit as h approaches 0 using the binomial expansion and all that, right? Okay, so what happens if you, oh, sorry, this is g prime. So what happens if you multiply f prime and g prime? That would be the product of the derivatives, and that would be 6x cubed, right? Now, if you multiply these two functions, it's the product of the two functions. That's x squared times x cubed, that's x to the 5th. If you differentiate this, you get 5x to the 4th. Whoops, very different. Okay, so this one example, I mean, simple example shows you that the derivative of a product is not the product of the derivatives. Okay, you may want to write that. What is that? What did I just say? The derivative of a product is not the product of the derivatives. So the limit does not necessarily work that nice. Limit theorems actually work nicely. If you recall, back in chapter 2, we learned that the limit of a product indeed was the product of the two limits if each limit exists, but that's not the case with the derivative. Why is it? Okay, what makes these different? We can't just assume these are equal because, you know, as we saw, it's different, right? So let's try to figure out what the derivative is. So what we want to do is to find the derivative of the product, fx times gx, right? So what is that? Well, you know, this is the limit. As h approaches 0, we have to go back to the definition because we don't know how to do this yet. It's f of x plus h. Remember, the product is just simply the product of these two values. So you have to evaluate f at x plus h and g at the same point and multiply these two numbers together. And then you subtract from this fx gx. And then you divide this by h. This is the difference quotient, and you have to take the limit of this. That's by the definition of the product, the derivative of this product. Okay. Now, what can you do at this point? I mean, you can't factor anything, right? So you have to have some creative ways of doing this. All right. So the first thing I want to do is here, let me just say it's going to be a long fraction. All right, and the denominator is going to simply be h. All right, now I'm going to do something that sounds crazy, and somebody came up with this, not me, but somebody came up with a clever idea. See, you can't really do much. So what is something that you can do to make this simpler? So you know, in mathematics, we do this often. You can always add and subtract the same quantity from an expression. So whoever came up with this decided, why don't we add and subtract, maybe subtract and add, f of x times g of x plus h. Now you see something similar in this top here, but it's not all that clear how this will help. But it turns out this is exactly what is needed to figure out the derivative of a product. Okay, now, first of all, I subtracted and added the same thing on the top of a fraction. So I did not change the anything here, right? So that's fine. And I'm going to draw another long line here. Okay, h is still the denominator. All right, now what you can see is on the first two terms, oh, what happened? I can't see this. In the first two terms, you have the common factor g of x plus h. So let's factor that out. And then the rest will be f of x plus h minus f of x. Okay, so this is from these two terms. Plus, now we are going to focus on these last two terms. Notice here f of x is a common factor. All right, and so now we, oh, that's going to be g of x. Okay, so that's how we can, manipulate and factor things out. If you notice here, I have something plus something on top and then dividing by h. So I can split this into two parts. And remember, the limit of a sum is a sum of the limits. So I can split this into two limits, assuming that the limit exists. Each limit exists. Okay, but this one, this limit actually looks familiar. Okay, somewhat. And then the second one is actually, what is that? You have fx on the top. And then the other part is g of x plus h minus g of x. That also looks familiar. All right, now, as h approaches 0, this just becomes g of x. So, and you can plug in, h is equal to 0. You can take this part out because that part is on the top and is not affected by h becoming 0. So it's g, oh, yeah, I guess I should say, it's still the limit of g, and then look what happens. By the way, the limit of the product is the product of the limits. So I am going to just go ahead and write this. And this part should look really familiar. It's the limit of f of x plus h minus f of x over h, right? You know the name for this. This is exactly what the derivative of f is. All right, now here, the second part. All right, first, you don't even have h in here. And then I'm going to write this as the limit of the product of two limits. But the second limit, again, should look really familiar. Okay, and that is, as you can imagine, or as you recognize probably by now, it's the derivative of g. So guess what? And by the way, at this point, h can be replaced by 0 for that one. So you have gx, and what in the world is that one? As I said just a few seconds ago, that's the derivative of f, okay? And now you have f of x times the derivative of g. There it is. This is called the product rule. All right, so let me go ahead and write this result, and I'll clean this. I'll just switch things around a little bit. The product rule tells you how to differentiate the product of two functions. The product rule says the derivative of a product is equal to the derivative of the first times the second plus the derivative of the second times the first. Okay. In red, I'm going to write this in a dx format. d dx of fg is equal to f. Sorry, I should move this a little bit to the front. Okay, so what this says is the derivative of fg is equal to d dx of f times g plus d dx of g times f. All right, so this is one for you to learn, to memorize. And as you practice this over and over, you will get this fairly easily, okay? But just make sure that you don't write the product of the two derivatives. You have to do f prime g plus g prime f. Now, some people use different orders like f prime g plus f g prime. As long as you have an equivalent form, it'll be okay. Okay, so let's go ahead and try to go back to that problem we were doing. Remember this? The the product of the derivatives was not the correct answer for the derivative of the product, right? So let's try to figure out x squared times x cubed. How do you take the derivative of that? So if you take the derivative of x squared times x cubed, now I am considering, I guess it's helpful if I say this is my fx and this is my gx. Okay, fx is x squared, gx is x cubed. What is the derivative of the product? Now we already know the answer because this is x to the fifth power. And as we did before, x to the fifth power differentiated is going to give us, where are we? It's going to give us 5x to the fourth. That would be our answer. But let's make sure and confirm that our product rule is at work. Okay. So remember, this is going to be, I'm going to write this as f prime g plus g prime f. Okay. F prime, that's going to be 2x because the derivative of x squared is 2x. G, without differentiating, is x cubed. Now g prime is 3x squared. F, without differentiating, is x squared. So now you have 2x to the fourth plus 3x to the fourth. And what do you know? This is 5x to the fourth, as expected. We knew this because x squared x cubed is x to the fifth, and the derivative is of x to the fifth is 5x to the fourth, right? So you got the same answer. Yay, the product rule works. And of course, the product rule works because it's been proved, right? And I show you the proof of this. Somebody clever enough was able to figure out, that adding and subtracting fxg x plus h is going to do the trick. And so thank that person who came up with that. All right, so that was the product rule, right? All right, now how about the quotient rule? Is there a rule for quotient? Yes, there is. Okay, and I'm not going to show you a proof of this one because it is similar to that. It also requires a little trick, but yeah, here. Let me just tell you the answer to that. The derivative of fx over gx. Okay. Unfortunately, this is quite more complicated than the product rule. Okay, so the first thing you remember here is you square the denominator. Why? Well, as I said, I'm not showing you the step-by-step proof of this. You can find it. In fact, our textbook doesn't have it written. But if you look at some other books, you can find the proof of the quotient rule. And then the top is going to be a little strange. Okay, it's going to be f prime times g minus g prime times f. So this top looks very much like the product rule, except it's the sign is minus in between these. And then you have the denominator, which is the quotient, the original denominator squared. Okay, so that is the quotient rule. And I present this without a proof.